Voyager 1 is on a crash course with no brakes. It's currently hurtling through the depths of space that no human-made object has ever been before. And it won't stop until something gets in its way. Like this alien planet it's about to crash into 75,000 years from now. You're about to see how the heck it got there and what happens when it does. As of today, Voyager 1 has been drifting through space for nearly half a century. It traveled to the edge of our solar system and then left us in the dust as it ventured out into interstellar space. The space probe's only modus operandi is to keep going and going and going. In 40,000 years, it's scheduled to pass a star that it wasn't even aiming for and continue into the void. And pretty soon, Voyager 1 will be so far away from Earth that humans will lose all contact and lose track of its location, making it anyone's guess as to where it travels to next. So what if, during its interstellar adventure, the spacecraft makes it all the way to an alien planet? And not just any exoplanet, the closest one to Earth, Proxima Centauri b. It's only a mere 40 trillion kilometers away after all. Would it simply bite the cosmic dust, come face to face with a comet? Or could it somehow survive, leaving behind an important message about humanity for extraterrestrial life? Well, before we can find out, Voyager 1 is going to have to take the longest journey in the history of spaceflight. So strap in, because things are going to get a little far out. Let's start here. See that tiny dot? The one that looks like a speck of dust that some clumsy camera guy forgot to clean off his lens? Well, look closer, because that's Earth. This iconic photo, known as the pale blue dot, was taken by Voyager 1 in 1990 when it was 6 billion kilometers away from us. And it sure has a way of putting our significance into perspective, or lack of significance. This photo is just one of over 67,000 incredible images that Voyager 1 and 2 took of space, transforming our understanding of the solar system, giant outer planets, their rings, and 48 of their moons. It's hard to overstate how much knowledge these probes have given us about life beyond our Earth. Their original missions were only supposed to explore Saturn and Jupiter, and the spacecrafts were only built to last 5 years. But incredibly, they've kept going, breaking new records every day and beaming down new discoveries. Pretty cool. Right now, as Voyager 1 is over 25 billion kilometers away, its signals take 23 hours to reach Earth. But that's about to change. In November of 2026, Voyager 1 will reach an historic milestone and officially become 1 light day away, meaning a signal sent from NASA will take 24 hours to reach the probe, and another 24 hours for the ping to return. To put this into perspective, the amount of time it takes for a signal to reach the moon is 1.3 seconds. To reach the sun, it's 8.5 minutes. So, yeah, I'd say Voyager 1 has been putting in some serious mileage since its launch in 1977. To achieve these feats, it's had a need for speed, moving at a velocity of 61,000 kilometers per hour. That's 38,000 miles per hour. But even flying at these rapid rates won't make its new adventure a quick one. To get to Proxima Centauri b, Voyager 1 will have to spend about 75,000 years in space. That's because this exoplanet, Proxima Centauri b, is located in an entirely different star system, Alpha Centauri. Here, Proxima Centauri b is one of the planets orbiting the red dwarf star Proxima Centauri. Now, Sure, it's technically the next closest star system to Earth, but it's still 4.5 light years away. Now, to start its journey, Voyager 1 has had a bit of a head start. It's already orbiting beyond the heliosphere. That's the sun's shield of armor from harmful radiation and cosmic rays flying through the rest of the galaxy. This big bubble around our solar system is created from the outward pressure of solar wind, and it's the final boundary before interstellar space. Voyager 1 and its twin vessel, Voyager 2, are the only spacecraft to ever have gone past it. Voyager 1 crossed this threshold in 2012 and kept on trucking. And with every new boundary it crosses, its 10 scientific tools on board beam us Earthlings new information about space. Its magnetometer measures the strength and direction of magnetic fields. These readings are how we know that it passed the heliosphere. Its cameras gave us the first detailed looks at Jupiter and Saturn, and its high-gain antenna is what has allowed NASA scientists to talk to Voyager all these years. Some of these tools have been turned off to extend their lifespan into interstellar space. This is essential because not only is Voyager sending signals from space, it's carrying one hell of a special message to space, the Golden Record. This onboard time capsule is full of photos, musical recordings, and scientific data about us humans. Think of it like the greatest hits of humanity. If alien life on another planet discovers the Golden Record, it'll give them a jaw-dropping glimpse into life here on Earth. Assuming they have jaws. Maybe tentacle-dropping? But here's the problem. Right now, Voyager 1's flight isn't on course to any planet. Its current path is headed toward the star AC plus 793888, also known as Gliese 445. But that star doesn't have any confirmed planets orbiting it. So Voyager 1 would need to change its direction. And that direction is about to enter the realm of our cosmic imaginations. Around 2036, Voyager 1 will be so far away that NASA scientists expect to lose its signal. Not because it's running out of the solar system, but because it's running out of power. Its energy supply comes from radioisotope thermoelectric generators mounted on a deployable boom. These convert heat from natural decaying plutonium into electricity. Pretty amazing. But they've been weakening over time, losing about 4 watts of power every year. In iPhone terms, that's like being at 1%, and that old frayed charger you've been holding onto for dear life is about to go kaput. After the last signal is received on Earth, Voyager 1 is now just a silent, drifting monument of humanity, essentially a ghost ship. But unlike a ghost, it can't just disappear into thin air, because there's no air in space. To get on the right track, Voyager 1 will need some sort of gravity assist. Like a slingshot, a gravity assist can add or subtract momentum to shoot a spacecraft in a different direction, change its trajectory. Artemis 2, the most current mission to the moon, used a gravity slingshot to change direction 180 degrees at the peak of its journey. A gravity assist is how Voyager 1 was able to reach interstellar space in the first place. By passing Jupiter in 1979, it gained 10 kilometers of speed per second and another 5 kilometers per second when it passed Saturn in 1980. While flying by these two gas giants, it essentially stole some of the planet's momentum by being sucked into their gravitational pull and spit back out again, like getting a speed boost in a video game. What's even more incredible is that scientists designed this effect. Known as the Grand Tour, Voyager 1 and 2 took advantage of a once in every 175-year alignment of planets, making pit stops to refuel on gravity and soar onto the next, reaching distances impossible by a conventional rocket. Now, the flybys of Jupiter and Saturn not only increased Voyager 1's speed, but in the process, discovered 2 new moons of Jupiter, Thebe and Metis, plus 5 new moons of Saturn, and a new ring named the G ring. Back to Voyager 1. To start altering its course toward Proxima Centauri b, it's gonna need to fly by something. But not just any wee star or asteroid. It needs help from one of the big boys, an undiscovered rogue planet in the Oort cloud. The Oort cloud is located about 5,000 times further away than the distance from Earth to the Sun. So, yeah, not exactly what you would call a stone's throw. It's so far that it's best not to measure it in kilometers or miles, and instead use astronomical units, AU for short. As we've talked about on this channel before, 1 AU, astronomical unit, is the distance from Earth to the Sun. It's about 150 million kilometers, or 93 million miles. Scientists estimate that the Oort cloud's inner edge is about 1,000 AU from the Sun, and its outer edge is about 100,000 AU. And not to be morbid, but, well, I'll be dead by the time Voyager 1 reaches it. It's gonna take 300 years. As Voyager enters this new frontier of the Oort cloud, our sun now just looks like a tiny twinkling star. And I hope you packed a winter jacket for this ride, because things are about to get chilly. Temperature here may be as cold as minus 268 degrees. That's minus 450 degrees Fahrenheit, or 5 Kelvin. Trillions of icy objects surround Voyager like moths at a porch light. These 4.6 billion year old frozen bodies are thought to be pristine relics left over from the formation of our planet, before gravity ejected them out past the borders of our solar system. And many of these objects are actually comets, an estimated 100 billion of them. And once something disturbs them, these volatile, dirty snowballs can go shooting off in any which direction, putting Voyager 1 in their crosshairs. Terrifying. Well, luckily for our venturing vessel, this exorbitant number of comets is spread out over an insanely vast surface area, helping it dodge disaster. Your chances of winning the lottery are 100,000 times greater than Voyager 1's chances of getting blown up into spacecraft confetti. After being neighbors with comets for 30,000 years in the Oort cloud, Voyager 1 finally encounters the gravity assist it's patiently been waiting for. A rogue, undiscovered planet lurking in its depths. Snagged from another solar system by the sun's gravity, a Neptune-like planet has come to call the Oort cloud home sweet home. Ah, cozy ice debris. The lonesome planet, though, is a sight for Voyager's sore eyes. And if you want to know more about this rogue planet, well, make sure to subscribe, because we've got a whole video coming out about Planet 9, featuring someone.
Someone cool, more like.
Sure. Moving on. By flying behind Planet 9 and into its gravity well, Voyager 1 lands its one-way ticket out of the Oort cloud, and in the process spins itself in a new direction. Destination? Proxima Centauri b. This kind of stealthy maneuver has been performed before by Voyager 1's twin, Voyager 2, when it passed Neptune's North Pole in 1989 and changed its trajectory by 45 degrees. Okay, at long last, through the Oort cloud, Voyager 1 enters another Oort cloud, the one surrounding Alpha Centauri, where Proxima Centauri b is located. Now, the length of this boundary is a little blurry, so let's give it another 10,000 years or so to get through it. After 40,000 years of travel, Voyager 1 has a new problem. As if hanging out in a snowstorm of comets wasn't bad enough. Its 40,048-year-old body, made of aluminum, is being put to the test. Now, space doesn't have oxygen to rust metal, but it does have galactic cosmic rays. These tiny superfast particles are menacing cosmic bullets of radiation, flying through the vacuum at light speed, getting fired by explosive events like stars going supernova. And they're a lot more intense beyond the heliosphere. Having now been outside that protective bubble of the sun for tens of thousands of years, Voyager 1 is no stranger to being pummeled by them. These particles have been causing long-term defects to the spacecraft, making it as brittle as a ceramic plate. One tiny impact in space would shatter it. Its risk of crumbling now is worse than a Love is Blind marriage. Seriously, Love is Blind? Is people still watching that show?
Oh yeah, it's like the #1 show on Netflix.
Number one?
Yeah, when it comes out with a new season, it's like premieres as #1.
How many marriages last?
It's high, it's like 60%.
Wow, there you go. Well, all right then. Well, crumbling like a Nick and Amanda wedding. No? That's not them? I'm more of a Survivor guy anyway. Okay, since I'm a betting man, let's say that Voyager 1 does make its date with destiny. 75,000 years, 10 dead scientific tools, and a trillion dodged comets later, it finally approaches Proxima Centauri b, and things are about to get lit. No, like literally lit. It's hurtling toward the side of this planet that has 30 times more extreme UV radiation than Earth. Add sunscreen to the list of things NASA should have sent with Voyager on this flight. And that daytime heat won't be cooling off into the nighttime. Because Proxima Centauri b orbits extremely close to its star, Proxima Centauri, it's tidally locked. That means its rotation rate matches its 11-day orbit. Kind of like how the moon only shows one face to Earth. One side is perma-frozen darkness, and the other side stays hot and sunny. But touching down here won't be any kind of tropical vacation for Voyager 1. More like an uncontrolled crash. Pulled by the planet's gravity when it came too close, Voyager wouldn't spiral to the ground. It would hit the atmosphere like a bullet. The entry velocity would be around 20 kilometers per second. With no heat shield, the probe would vaporize instantly. The cameras, booms, a high-gain antenna would melt. Only the general-purpose heat source modules, the heavy-duty shells around the nuclear batteries, would survive. Any leftover particles from the burnt-up metals would eventually cool and become dust in the wind. Stellar wind. Unlike terrestrial winds on Earth caused by the movement of air, these gusts would be more like hot flows of gases, sneezed onto Proxima Centauri by its star. Then it would be time to face the music. On the golden record. Remember that 1977 phonograph hitching a ride on the Voyager 1? Just waiting for its debut release in the cosmos? It's been holding on to everything from sound recordings of insects to a message from then President Jimmy Carter, and a plethora of bangers from artists like Mozart, Louis Armstrong, and Chuck Berry. Now, I personally think that Bruce Springsteen's Born to Run would have been a better choice to display the sheer greatness of human achievement, but I wasn't consulted. The committee that put it together was headed up by famed astronomer Carl Sagan. They also chose snapshots of life on Earth to put on the golden record. Human sex organs, Taj Mahal, a woman eating ice cream, sailboats, daffodils. Heck, when you look at it that way, life on Earth isn't so bad. That's because the committee also made a conscious decision not to include any photos of crime, poverty, disease, or war. It's like Earth put together a dating app profile, only showing its good side, holding up a fish. A little biased, but who doesn't want to put their best foot forward? Am I right? But back to the phonograph. The good news, it's fared better in space than it would have on Earth, with less to erode it. The bad news? Well, after 75,000 years in the ether, it would be blasted by interstellar dust and lose all of its data. So that recording of crickets would now just be crickets. Oh, the irony. While the high-frequency data might be sanded off by dust, the record itself is incredibly dense, and since the golden record is technically gold-plated copper housed in an aluminum jacket, it wouldn't necessarily be destroyed by the atmospheric entry. It may actually be the only thing that survives a total meltdown. But there's no doubt it would be a little worse for wear, most definitely warped or even buried by the impact. But what if an alien civilization found this long-lost remnant of Voyager? While they might not be able to rock out to Johnny Be Good, if they were advanced enough, they could determine where the probe came from. And that's thanks to a hidden message on the cover of the Golden Record. Pulsar map. The starburst-like engraving is like a cosmic GPS showing exactly where the sun is, located relative to 14 pulsars. These pulsars are the spinning remains of dying stars, and they act like lighthouses when their magnetic fields cause them to emit beams of light. If extraterrestrial light could decipher the map, well, it would be like finding a cosmic return to sender address. It's important to keep in mind that what we know about Proxima Centauri b today might be different in 75,000 years. Scientists can really only make their best estimates about what its atmosphere is really like. So, just for fun, let's say that Voyager 1 somehow survived its journey to the exoplanet. Well, it would take 4 light years, 40,000 Earth years, for its signal to reach our planet, and another 4 light years for Voyager 1 to receive anything back. But even if humans could whisper some sweet nothings to Voyager 1, sadly it would be doomed. Though it was designed to carry a message for extraterrestrial life, it just wasn't designed to stay on an alien planet full time. And though it may not rust away like it might on Earth, it would likely meet its match eventually with some kind of catastrophic impact. Given that some scientists suspect that there could be an asteroid belt near Proxima Centauri b pounding rocks at the planet, things aren't looking too good for Voyager 1. But then again, as the saying goes, life's about the journey, not the destination, right? So, for the spacecraft that's made the furthest trip known to us, broken countless records, and shared fascinating clues about the uncharted depths of interstellar space, I'd say it had a pretty damn good ride. Today, we're bringing distant exoplanets closer to home. How much closer? Well, we're moving them right into our solar system. We'll start with TRAPPIST-1e. TRAPPIST-1e is a terrestrial planet, just a little smaller than Earth. Back in its star system, 41 light years away, this world orbits extremely close to its star. But it's okay because that star is tiny. Yeah, TRAPPIST-1, that's the star, is smaller, redder, and way colder than our sun. It's classified as an ultra-cool dwarf star. Nice. The distance between TRAPPIST-1e and its star is only about 3% the distance between Earth and the Sun. And that's actually within the habitable zone of this tiny star, TRAPPIST-1. Now, when we were deciding where to move TRAPPIST-1e into our solar system, we thought placing it as close to the Sun as possible would be a great move. But not at the same distance as it orbits its own star now, because at 0.03 astronomical units, our sun would crisp this world up like a piece of burnt toast. No, we're going to find a cozy spot for TRAPPIST-1e in the orbit of Mercury. The orbit of Mercury is about 0.4 astronomical units from the Sun. That means that TRAPPIST-1e would be orbiting the Sun 13 times further away than it orbited its own star back in its star system. But the Sun is bigger and hotter than TRAPPIST-1, so even in this faraway orbit, TRAPPIST-1e would be getting a lot more sunlight. The surface temperature on this alien planet would jump to extreme levels, too. And this heat wouldn't take long to hit TRAPPIST-1e. No, this planet would become scorching in a matter of days. And within years, well, whatever water might be contained on this planet would boil away. So, if we're thinking in terms of habitability, that's bad news for TRAPPIST-1e. Habitability-wise, back in its own star system, TRAPPIST-1e is the most promising of all its TRAPPIST neighbors. Yeah, it has 6 rocky planetary neighbors. Some of those planets are boiling hot, too hot for any life to exist on them, and some are frozen worlds, but TRAPPIST-1e kind of rocks. It's right in the habitable zone. It's got an atmosphere, land, lakes, and oceans. It even has similar gravity to Earth's. TRAPPIST-1e is no doubt our best candidate for Earth 2.0. Or at least it was before we moved it into Mercury's orbit. Now, any hope we had to make this planet our home away from home would be gone. The cool thing is, in Mercury's orbit, you'd be able to see it from Earth. Yeah, it would be a dot in the sky, but a bigger and brighter dot than Mercury. Even without a telescope, it would appear as a bright star. Another piece of good news is that placing an exoplanet 2.4 times larger than Mercury in that orbit wouldn't cause significant gravitational damage to our solar system. It might nudge Venus slightly, but that would take thousands of years. So yeah, bad news for TRAPPIST-1e, but not so bad for you on Earth. Hey, now that this exoplanet is so close, you could finally land on it. Or really land on whatever was left of this once possibly habitable world. Now, to make things a little fairer for TRAPPIST-1e, we should place it closer to Earth's orbit, like in the asteroid belt. The asteroid belt is this region of space between Mars and Jupiter. It has millions of asteroids in it. But unlike in Star Wars: The Empire Strikes Back, these asteroids aren't closely packed together. The average distance between them is around 1 million kilometers, 600,000 miles. There's plenty of space for TRAPPIST-1e. But the asteroid belt is 2.5 times further from the Sun than Earth is. So in this position, TRAPPIST-1e would only get 16% of the sunlight that we get here on Earth. Once again, bad news for this exoplanet. It would quickly lose all its heat and turn into a frozen wasteland. All of its water would become locked into water ice. At this point, it would no longer be Earth 2.0, it would be a new Mars. If TRAPPIST-1e did have any hint of life, it would be obliterated. Unless that life was beneath the surface and could adapt to this sudden climate change. But here's where things get interesting for our solar system. A planet almost as large as Earth in the asteroid belt would not be good for you. Okay, at first it would be business as usual, but over millions of years, TRAPPIST-1e would yank asteroids out of their orbits. Its gravitational effect would grow, and millions of years later, it would start disturbing the orbits of Mars and Earth. Even worse, it might start affecting Jupiter's orbit. And when that giant of a planet shifts orbit, well, the entire solar system is in danger. Yeah, even a slight shift in Jupiter's orbit would affect all the inner planets. It might even send Mercury crashing into the Sun. But that would take billions of years, so nothing to worry about for now. Okay, clearly TRAPPIST-1e would have no luck in either of these orbits, and placing it too close to Earth would be dangerous for our planet. So let's try moving another exoplanet, Kepler 442b, into one of our spare rooms. Kepler 442b is a heavyweight of rocky planets. It's 1.3 times the size of Earth and packs 2.3 times our planet's mass. It's like Earth on steroids. or as scientists call it, a super Earth. Now, one moment it's orbiting its cool orange dwarf star 1,200 light years away, minding its own business, and the next moment it's teleported to our solar system. But where do we put it? Well, back in its own star system, where Kepler 442b is the one and only rock, it happens to orbit its star's habitable zone. But that star, Kepler 442, is a K-type star, which is cooler and dimmer than our Sun, a G-type star. So 442's habitable zone is way closer. If we replaced our Sun with Kepler 442, that would place Mercury in the habitable zone, and Venus would be just outside of it. But we're not replacing the Sun here. We're just placing Kepler 442b at about 0.5 astronomical units from the Sun. Yeah, a bit closer to Mercury than to Venus. Now, that's no longer within the habitable zone of the Sun, and that means, well, things are about to get hot for Kepler 442b. However, what makes Kepler different from TRAPPIST-1e is that Kepler 442b has stronger gravity, so it would fight for its atmosphere. Yeah, we believe that Kepler 442b is a great candidate for a habitable world. It's bigger than Earth, so it would have a lot more surface to live on. But let's be honest, we're not going to travel 1,200 light years to settle there. And here, so close to the Sun, this planet isn't going to be a tropical destination. It would be hellishly hot. Its oceans would evaporate, but the atmosphere would stick around. And that's a bad thing, because instead of a super Earth, Kepler 442b would become a super Venus. Yeah, all that vapor from evaporating oceans would make its thick atmosphere even thicker. And in the same way that Venus traps its heat on the surface, Kepler 442b would do that too. Except that Kepler 442b is almost 3 times more massive than Venus. Its strong surface gravity would hold on to the thick atmosphere, and after years of intense solar heat, this atmosphere could grow even denser. And if greenhouse gases began to trap more heat, it might end up even worse than Venus. You definitely never want to land there. And eventually, you might not be able to land there, because having a brand new super Earth in the inner solar system, it would shake things up. It would start slowly, and at first, you wouldn't notice anything, but after a few thousand years, Kepler 442b's gravitational presence would push the orbits of Mercury, Venus, Earth, and Mars. After millions of years, Kepler 442b might even toss those planets out of their orbits and make them collide with each other. And as that orbital mashup is unfolding, things would be changing down on Earth too. With an unstable orbit, Earth would have an unstable climate. And if we were on a collision course with Mars or Venus or even Kepler 442b itself, well, that would be the end of our planet. But these events would take at least 1 million years. You wouldn't see any planetary collisions in your lifetime. So let's go bigger and move a planet 5.5 times more massive than Earth. Yeah, Q Ogle 2005 BLG 390LB. This exoplanet is incredibly cold and super far. Yeah, Ogle 2005 BLG 390LB, we'll call it Ogle for short, is 21,526 light years away. Ogle orbits its star at a distance of 2.6 astronomical units. If it were in our solar system, well, it would be sitting in the asteroid belt between Mars and Jupiter. Now, we don't even know what type of star this planet orbits because its star is just too faint and too far away. But it must be some kind of cool star because Ogle is a frozen world. It's colder than anything we have in our solar system. Yeah, Ogle's surface temperature is only 50 degrees Kelvin. That's minus 223 degrees Celsius, or minus 370 degrees Fahrenheit. It's cold. And because we discovered this planet through gravitational microlensing, we don't even know how big the planet is. You see, there's different ways of discovering planets. Telescopes like the Kepler Space Telescope discover planets through the transit method. They look at light blocked by an exoplanet passing in front of its star. Gravitational microlensing is different. It measures the tiny bending and magnification of light from a more distant star. That bending is caused by the gravity of a planet when its host star passes in front of it. So we don't technically see the planet, we just know it's there, gravitationally affecting the light from its star. And that means Ogle could be a super Earth, or it could be a mini Neptune. For the sake of this experiment, let's imagine Ogle as a big, frigid, rocky planet. Now, if we move this planet into our solar system, right in the asteroid belt, it would be a huge change for Ogle. The asteroid belt gets about 16% of the sunlight that Earth does, which is a lot compared to Ogle's original orbit. But it's still not enough, not at first. The surface would remain deeply frozen, but it would warm up to about minus 200 degrees Celsius. But the longer it's in our solar system and the more heat it gets from the sun, Ogle would slowly warm up. Its surface ice would partially sublimate, creating an atmosphere, or adding to its atmosphere if Ogle already has one. Still, it would be too cold for us to land on, so we'd likely just send probes and rovers to explore the surface of this cold planet. Keep in mind that this isn't a small, lightweight planet like TRAPPIST-1e. Ogle is massive, 5.5 times heavier than Earth. It could be extremely dense and have a strong gravitational pull. Within a few million years, it would cause the asteroid belt to fall apart. The asteroids would be ejected of their orbits and flung forward, spiraling toward the sun. And some of those asteroids would take detours near Mars and Earth. Our daily weather forecasts on Earth would be calling for bright sunshine, light solar winds, and a 70% chance of catastrophic asteroid collision. The asteroid belt has millions of asteroids, and at least 1 million of those are a minimum 1 kilometer in diameter. That's 0.6 of a mile. So things would get disastrous fast. Eventually, after tens of hundreds of millions of years, Ogle would destabilize Mars, and once Martian orbit shifted, Earth would be next. So if humanity somehow made it to tens of thousands of millions of years, a giant asteroid might just wipe us out, like the dinosaurs. But things would get much worse, much faster, if we placed an epic super Saturn in an orbit around the sun. This is J1407b, and it's magnificent. It orbits a star 434 light years away from us, and it is truly massive. J1407b is 20 times more massive than Saturn, but its rings are 200 times wider than Saturn's. Yeah, if we placed this alien gas giant in the same orbit as Earth, its rings would reach Mercury. Back in its own star system, this super Saturn orbits 10 to 15 times further from its star than Earth does. So in our solar system, that would place it perfectly between Saturn and Uranus. Now, those giant rings would dominate the sky. They'd reflect so much sunlight that you could see them from Earth. Though in its new orbit between Saturn and Uranus, you'd need a telescope to see them properly. But let's not forget, this planet is massive. It would be tugging at Saturn and Uranus, slowly disrupting their orbits. Over millions of years, this gravitational dance would destabilize moons, shift rings, or even pull Uranus into a more elliptical path. Smaller, icy bodies in the Kuiper Belt would no longer be safe. J1407b's gravitational reach would act like a celestial broom, sweeping entire regions of debris clean or hurling them inward toward you on Earth. Yeah, expect a higher number of asteroid collisions. Now, let's say we wanted to explore this absolutely magnificent giant and its rings with a probe flyby. Well, that could be difficult. Those rings aren't just icy rocks. They're millions of chunks, some as large as mountains, orbiting J1407b at thousands of kilometers per hour. A direct impact would vaporize a spacecraft. Now, J1407b might have hundreds of moons. Some could be larger than Mercury. If they cross into Saturn or Uranus's orbit, they'd crash into those planets. They might even make Saturn and Uranus's own rings bigger and brighter. If J1407b nudged Jupiter even a little bit, the effects could eventually ripple inward toward Earth. Jupiter is the anchor of our planetary orbits. If J1407b disturbed it, it would throw off the entire balance of our inner solar system. Over hundreds of millions of years, those tiny changes would add up. Earth's orbit could wobble. Asteroids would be smashing into us. Mercury might even get flung into the sun. Yeah, it gets chaotic. 635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What If guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. Now, you might have heard of the exoplanet that I'm going to. It's called Kepler 22b, and it's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler 22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely, 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this. Well, hello, Kepler.
The Kepler 22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler 22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, It means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing like it would on Mars. And the Kepler-22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler-22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or like earthquakes. Kepler quakes? But like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler-22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water and the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. Whew. It's been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Give up, Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Okay, let's land. Whoa, this atmosphere is thick. Rico, give me some stats on this planet.
Kepler-22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler-22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. Oh. That feels nice. I can go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Ooh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler-22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler-22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler-22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because With no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler 22b, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler 22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler 22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler 22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. All this walking around makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's wrong.
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. But don't worry, he'll show up for his next adventure.
You might be wondering how I get into these situations. Well, let's roll it back a little.
Triton, Neptune's gargantuan moon. It's one of the strangest rocks in the solar system. It orbits backwards, hides an ocean possibly filled with life, and is covered in ice volcanoes.
Titan, my old nemesis. That's right, guys. It's time for my Titanic return to Titan. Sure, you got me last time with some clever laking, but I'm headed back your way for some sweet, sweet revenge, baby.
Okay, one, how do you take revenge on a moon? And two, we hired you as our intergalactic rep to spend 5 seconds on Triton.
Yeah, Titan.
Triton.
Oh, right. Triton. I mean, I knew that, and I'm pretty sure I punched Triton into, the navigation thingy.
Incorrect. You navigated to Titan. You are currently on Titan.
Well, Titan, Triton, tomato, tomato, it's the same thing, really. They're kind of like moon cousins, right?
Wrong. They're moons of two completely different planets. Titan orbits Saturn. Triton orbits Neptune.
Oh boy. Neptune. Ugh, I died there too. Wow. Wrong moon, eh, Rico? What a team botch job we did on this one. You and me.
Negative. You were the one responsible for the mistake.
Cool. So, how far away is Triton from here anyways?
Triton is 4.5 billion kilometers away from the sun, and you are currently 1.4 billion kilometers from the sun. So do the math, and you're just over 3 billion kilometers away from the correct moon. And that's only because Saturn and Neptune happen to be relatively close at this point of their orbits. While Saturn revolves around the sun once every 29 years, Neptune, with Triton tagging along, takes almost 165 years to complete its orbit. That means that when they're at the opposite ends of the solar system, Triton and Titan are almost 6 billion kilometers apart.
Oh man, so many billions, and none of them in my bank account. Well, one is. It's just got a nasty minus sign in front of it.
Yeah, you'll get there. And by there I mean Triton.
Oh, fine. Let's go to Triton then. And I was all set to go cliff diving and everything.
Triton is the biggest moon of Neptune. You remember Neptune, the icy blue gas giant and the outermost planet in the solar system? Well, Triton is just as colossal. It's not as big as Neptune, I just mean it's really big for a moon. With a diameter of 2,700 kilometers, it's bigger than dwarf planets like Pluto, though it's slightly smaller than our own moon. What makes Triton cool, other than a glacial surface of minus 235 degrees Celsius, is that it's the only large moon in the solar system in retrograde orbit. This means it orbits in the opposite direction of the planet's rotation, which is a real space oddity.
Ha! Who's botching the job now, Triton? You're going the wrong way! Are we going the right way?
That's actually right. Scientists think Triton's retrograde orbit indicates that Triton didn't form with Neptune. No, instead, it was captured by Neptune's gravity from the nearby Kuiper Belt billions of years ago.
Oh, so like Triton's kind of like a kidnapped moon. Dope.
Sure. Triton's orbit isn't just retrograde, it's dramatically tilted. Most of Neptune's moons circle neatly along the planet's equator, but not Triton. Triton's orbit is tilted at a wild 157-degree angle. That's another clue that it wasn't always Neptune's moon. Triton's surface is a frozen mixture of nitrogen, water, and methane ice. Even cooler, literally cooler, it constantly resurfaces itself with cryovolcanoes. Only a handful of places in our solar system, like Triton, Earth, Io, and a few icy moons, have any kind of volcanic activity at all.
Wait. Volcanoes? I thought you said it was cold.
Oh, it's cold. These aren't just regular volcanoes. These are ice volcanoes that erupt slushy mixtures instead of lava. And they can vent plumes of ice and vapor 8 kilometers into Triton's atmosphere.
Ice volcanoes. That sounds like a dope-ass D&D spell. Summon cryovolcanoes. I didn't actually do anything, though.
There's a lot we still don't know about Triton. We've only been there once, way back in 1989, when Voyager 2 did a flyby. It managed to take images of the surface from about 40,000 kilometers away. It didn't have a chance to map the entire moon, but it photographed 40% of its surface. Triton was the last object Voyager 2 checked out before heading into interstellar space.
Voyager took pics of Triton before humans even had smartphones. Couldn't even post it to Moonstagram. It's not really a real thing. That's what's called wordplay. So if there's cryolava, does that mean there's cryolava cakes? And is it cold and sweet at the center, or is it molten lava?
I suspect they're just cold. There's a lot of ice on Triton, but you're onto something with the liquid center. Scientists think that all that ice hides a metallic core, a thick layer of rock, and a water ocean under it. And that ocean could, theoretically, support life.
Ah, sort of like a frozen onion with a metal core.
Who knows what'll kill you on Triton, or what you'll find there.
Ah, the cryovolcanoes. That was the name of my first emo band, except we never formally had a name because they fired me before the first gig. Still stings, and I still can't play guitar. But I'm definitely finding cryovolcanoes. In 5 seconds, I've lasted longer on alien planets. I'm definitely lasting 5 seconds on some backwater moon. Rico, are we any closer to Titan?
Triton,
Yeah, that's what I said.
calculating travel time, 4.9283 years.
5 years just to spend 5 seconds on some icy rock? Man, the things I do for my subscribers.
Approaching Triton. Have you learned to play guitar yet?
Huh? Yeah, a lot of music theory. Hey gang, Chase here, finally on the outskirts of Triton where I'm gonna spend 5 seconds in heaven, but like without going to heaven, you know? Anyhow, I've been knuckling down, doing some investigative journalism, grinding, doing the work, and when I find out, Triton's even more fire than Peter made it sound. It's a moon killer, baby! Well, stick around for my epic Titan landing.
Triton,
That's literally what I said, Rico.
That's right. Neptune has a surprisingly small number of moons for a planet of its size. But while Jupiter has almost 100 moons and Saturn has a whopping 274, Neptune only 16 moons. And Triton accounts for 99.7% of their total mass. When Triton was captured by Neptune's gravity, it came barreling in the wrong direction. Its backward orbit wreaked havoc on Neptune's original moons, causing violent collisions that pulverized many of them. Over time, Triton either smashed most of Neptune's other moons or catastrophically warped their orbits and sent them shooting out of the solar system.
Like I said, moon killer. Triton ate other moons as lunch or kicked them to the curb. An even crazier fact is Triton and Pluto might be like space twinsies. Pluto has like basically the same vibe as Triton, right? Kind of like Matthew McConaughey and Woody Harrelson, right? Are they best friend pals or are they brothers? You know, we may never know unless we can do a DNA test on dwarf planets. Can we? Rico, look into that.
You're probably thinking of NASA's New Horizons probe that flew by Pluto in 2015. It discovered that Pluto and Triton both have similar mass, density, temperature, diameter, and they both have active surfaces. Pluto has massive nitrogen ice formations, like Triton, including humongous nitrogen ice glaciers and maybe an internal water ice ocean. So it's entirely possible that they have similar origins.
Yeah, and the craziest thing is, Triton's got cantaloupes, huge, juicy melons everywhere.
Actually, it doesn't have cantaloupes. It has cantaloupe terrain, extensive fields of icy dips and ridges thousands of kilometers long. For the scientists who first studied Triton when the Voyager photos came in, it resembled cantaloupe skin, so cantaloupe terrain.
Disappointing. Disappointing, Peter. Well, gang, let's do it. 5 seconds on Triton. some turbulence here?
Affirmative. Mild turbulence stems from contact with the atmosphere.
What now?
Triton has a very thin atmosphere, 70,000 times thinner than Earth's. It's mostly nitrogen with trace methane and carbon monoxide. The majority of it is coming from those plumes over there, which are venting nitrogen from the cryovolcanoes.
Plumes. Now this is getting interesting.
The thing about a thin atmosphere, it's deadly. You can't breathe it, but it can boil you. On Triton, the pressure is so low that if you took off your helmet, your saliva, tears, and the moisture in your skin would start to boil, even though it's freezing. What am I doing out here? Then comes the explosive decompression. Your lungs rupture and you lose consciousness in less than 15 seconds. No oxygen, no air pressure, just instant death.
I'm sorry, did you just say explosive decompression?
And if that wasn't enough, Triton's average surface temperature is minus 235 degrees Celsius.
Don't like the sound of that.
That's just 38 degrees above absolute zero, the coldest possible temperature in the universe. Any exposed skin would freeze solid almost instantly.
From a million miles away and using 1989's tech, I could see how this would be cantaloupe. But from up here, up close and personal, it kind of looks like the world's saddest beach. Ugh. Let's go pluming. What's down that way?
That's the Leviathan Patera, a caldera formed by cryovolcanism.
The Leviathan Patera. Okay, that could have been my name for my doom metal band if they didn't fire me. Still stings, and I still don't know drums. Let's do my cold 5 there.
Warning. Unstable surface. Collapse imminent. Landing unsafe. Rerouting.
No, don't reroute, Rico. Okay, just open the door. It's just 5 seconds. Rico, abort! Collapse imminent! Let it take off! Reroute! Do whatever you were gonna do, smart robot man!
Rerouting.
Oh, that was close. Good scoop. Scoop. Get it? Right? Because it's cold, chase ice cream, and you kind of scoop me up.
Was that a joke?
Yeah.
Initiate laugh track.
Okay, forget it, Rico. Let's go pluming. Whoa! It's like a fire hydrant went to the dark side. Hey, Rico, is that ocean water shooting out?
Negative.
That's not ocean water, it's cryomagma, a mix of nitrogen and water blasting out from under the surface. It's exploding because sunlight heats up dark material below the ice, building pressure until boom.
Cryomagma? Ugh! So many band names, so few actual bands. So, not ocean water.
We don't know for sure if Triton has an ocean, but scientists think it might. Thanks to natural radiation, Triton's dense core of rock and metal could be warm enough to keep water melted beneath the ice.
And where there's an ocean, there is life. David Attenborough nailed it.
Yeah, if there's an ocean and it sits right on top of Triton's rocky core, that could allow the right chemicals to mix, like carbon, hydrogen, and nitrogen. It could be enough to support life. Now, what kind of life? No one knows. It could be tiny microbes, or if it started early and lasted billions of years, maybe something more complex. Just north of the Martian equator lies a 45-kilometer wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind: life. On February 18th, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years. Kind of like using your roommate's spice rack. What? I thought you said it was communal. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With the combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into the Jezero crater, we could encounter spores associated with a relatively recent geological era. And on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it. This creates a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board the rover, only a few dozen samples can be collected. So, no pressure, and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures on Earth. Biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft and then returned to Earth. Whoa, this looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA. In 1543, Copernicus boldly shook the status quo with his theory that the planets orbited the sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is the Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecrafts from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life. But another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens. Mind you, it's possible that life on Mars didn't have the right conditions to start at all. Or maybe it died off from an extinction event, similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. If Mars is your bag, well, have you ever thought about setting up shop there? With recent developments in rocketry, colonizing Mars might be possible in our lifetime. You better strap in, because that's a story for another What If. Voyager 1 is on a crash course with no brakes. It's currently hurtling through the depths of space that no human